Good afternoon, everybody. Thank you for sticking around for my presentation. It is an honor and a privilege to be invited to speak with you all today. We're going to get started because I have 20 minutes and I got a lot to cram in today. Let's get started. My name, for those of you that don't know me, is Andy Thompson. I have the coolest job at CyberArk, where I am the research evangelist for CyberArk Labs. We're a team of about 30 cybersecurity researchers, vulnerability researchers, reverse engineers, pen testers, you name it. And we create some amazing content, and I'm going to share with you some of that today. I'm SSCP and CISSP certified by ISC², and I'm a GX certified pen tester. I happen to also be a very active member in the hacking community of Dallas, Texas, where I am one of the organizers of the Dallas Hackers Association. About once a month, about 150 hackers will descend upon a Korean karaoke bar, and we do amazing talks, and very similar to what we're doing here today. I'm known there as the resident travel hacker, whereas I normally do regular computer sort of hacking. I also do travel hacking, which is taking advantage of like frequent flyer programs and loyalty programs, and my wife and kids and I, we travel all over the world on a shoestring budget. If you want to get in touch with me, my email address is as follows. I'm constantly posting the latest and greatest research from CyberArk Labs on LinkedIn, Twitter, Mastodon, and other social networks. So please come reach out, and I'd love to chat with you. We're going to be talking about, again, the research that comes from CyberArk Labs. This team, again, does some amazingly incredible bleeding-edge research when it comes to cybersecurity. And this is just one of the initiatives that we focused on today. We're going to be really focusing on browser secrets and what those secrets are, okay? You're probably already familiar with most of them, but we obviously have passwords, right? Passwords, but there's so much more that is contained within a browser. We have cookies, which we'll go into in depth in a second, but other additional information like credit card data, stored addresses, all of this is at stake and at jeopardy here. And we're going to show you how one can harvest these sorts of secrets, okay? So this is really the gist, the agenda slide here. And unfortunately, the art department decided to rip out all my funny memes, okay? So imagine there's a picture of a cat on the screen, okay? I love cat memes, and it's a scared cat. We're going to show you a way. My grandmother actually told me this a long time ago. There is multiple ways to skin a cat, okay? And so what we're going to be doing is skinning a cat 5 different ways and stealing passwords. The first is keyed-in data. We'll go into each of these in depth in a second here. But then we're going to talk about inline attacks, intercepting the communications and harvesting passwords, harvesting cookies that way as well. Then we'll talk about some really fun stuff. And really, this is where Endpoint Privilege Manager will really showcase itself. We'll talk about passwords that are stored on files on disk, and the most exciting part, the part where we talk about the research of CyberArk Labs, specifically focusing on browser secrets contained within the memory of the running process. And then last but not least, we'll talk about how you can just simply ask the browser as a standard user in order to get these secrets. And that's a real key thing I wanted you to take away from today's presentation. Every single demo that I do is going to be done as a standard user with no privileges, okay? So with that said, let's get started and focus on our first method of harvesting passwords and cookies and the like. The first is keylogging. You're probably familiar with keylogging. This is simply recording each keystroke one at a time, right? There's 2 styles of keylogging that we see in the world today. There's the hardware-based keyloggers, which are the USB dongle that sits between the keyboard and the computer. But there's also a new style of covert keylogger. This here, folks, is the OMG cable. This masquerades and fully functions as a USB-C cable, Apple Lightning cable, you name it. But inside of it, it's actually broadcasting its own pirate wireless signal so that other device can connect. And not only intercept the keystrokes that are being sent from the computer, but can also do keystroke injection, but that's for another day. The other style of key logging is more software-based, and this is just about built into every command and control framework that's out there. There's tons of free and open source projects out there that do key logging. There's a ton of them that are available. In fact, you probably have a keylogger on your phone right now and you don't even realize it. I'm not going to make you raise your hand or anything, but TikTok. Yeah, TikTok. Their in-app browser supported JavaScript keylogging, meaning that if you logged into any website through that TikTok app, those keystrokes were being sent to a third-party server. So just be aware of that. Now, in my presentation today, we're going to do, I think, 8 different demos. We're going to start very, very simple. I'm just going to show you a very simple keylogger. This, folks, is a basic Windows keylogger. And it's simply, we're just going to log on to a website with the keylogger running. We'll stop the process, and then we'll analyze the results, okay? So here we have logging into the Dallas Craigslist site. I'm going to wipe away my pre-saved password and just type it in manually here. And you can see we're typing it in. And bada bing, bada boom, we're into Craigslist. Now at that point, the attack's done. What we'll now do is we'll jump into the application, the keylogger, stop the monitoring, and then review the results. And you can see, plain as day, we have our password here. Positive horse battery staple. Complex, long password. I'm hoping one of you laughed a little bit, right? Anybody know what this is a reference to? Well, if you don't, this is a keylogger called a comic called XKCD that apparently Legal ripped out. So go check out XKCD, and it'll teach you all about how to create a very strong, complex password. That also makes it very difficult to brute force. Now, the most important part about my presentations is not to wow you or scare you with these demos, but to talk about how CyberArk can mitigate these sorts of attacks. And so there's several ways that we can go about thwarting keyloggers. Specifically, we can look at it from an application control perspective. There are applications out here like GhostPress or KL Detector that will detect the presence of a keylogger in the running processes. But EPM can do it just as just as well, or if not better, in the prevention of installing or executing malicious software. So application control goes a very long way in stopping keyloggers. Additionally, password managers go an extremely long way in thwarting keylogging attacks. Because if you think about it, if the password manager is putting the password into the proper field, no keys are being logged, no keys are being pressed, so there's nothing for the keylogger to intercept. So as far as how we mitigate a keylogger attack is, again, through application control and password management. The next style we're going to talk about is called an inline attack. You may have heard about this as an adversary in the middle, machine in the middle. Simply put, what we're doing here is analyzing the traffic. Normally, a client would talk to a server directly, but in this inline attack, essentially, we're having some sort of an adversary sit in the middle, intercepting, digesting that information, parsing out the credentials as they come about. And to be honest with you, this isn't just specific to browsers. Keyloggers, inline attacks like this are vulnerable at the operating system level. So this isn't just particular to browsers. Now, there's 2 different styles of inline attacks. There's the network style, where we, like, for example, Evil Gen X and Evil Proxy here. These are proxy level, network layer inline attacks. So you can see here that on the dark web, this Evil Proxy is being pitched on the dark web for sale. And this, again, once installed, routes all the traffic through a server that can then sniff out and steal those passwords. The other way is through social engineering. By tricking a user to go to what they think is a legitimate site, we can really do a lot of damage. And so what I'm going to demonstrate now is from TrustedSec. This is Social Engineering Toolkit. This is a basic, simple phishing attack. This is built out of Kali Linux. They're downloaded, or ISO I downloaded. It took me about 5 minutes to download this, and away we go. What we're doing here is we're selecting the fact we're doing a credential attack. Set SET, contains many pre-built templates. The one that we're going to be using, I believe, is Twitter in this demo. So once we've started the set web server, it's cloned the template of Twitter. Now we just need to convince our mark or our victim to go to that website. So they go to the secure or not secure website, whether it be through domain squatting, DNS attacks, phishing attacks, you name it. But as soon as the user logs in, they present their username, their password, oftentimes a multi-factor as well, and they get parsed straight through the website. But on the back end, this is what the attacker sees. You get the username, the password, right there in clear text. Now, SET is a very, very basic, very simple framework. The more mature social engineering frameworks also support multi-factor authentication as well. So they'll take that multi-factor token and just pass that through along with the username and the password. So how do we go about mitigating these sorts of inline attacks? This one is a little bit out of scope, honestly, from a CyberArk perspective, but I think it merited mentioning it as well here. The first is encryption, making sure that we're validating our certificates, making sure that we're going to the right servers and that the traffic is not unencrypted so that prying eyes can't see that sort of thing. But I think what makes the most sense here is end-user awareness training. Beyond anything, I think end-user awareness training is the most valuable security control, hands down, across the board. And so making sure that our users are aware of social engineering attacks, like phishing, for example, will go an extremely long way in preventing inline attacks. All right, so now we get to talk about the stuff specific to Chrome browsers, okay? The Chrome browser is actually running what's called Chromium under the hood. And Chromium is the foundation for not just Chrome, but Internet Edge browser, Komodo, and a bunch of different other browsers. And so the tactics that I'm going to showcase now apply to all of those, okay? Now, the first one we're going to talk about, again, is secrets on disk. The good thing about this is that password file is encrypted, so you're safe. Not really. You're actually quite not safe because it's actually encrypted using DPAPI encryption, meaning that if you're logged in as that user, it's very easy to decrypt that file. It's an environment variable that's stored as while the end user is logged into that machine. Okay, so what that means is as long as you're running within the context of that user, you can read this particular file. It's app data, local Google Chrome, user data, default login data. I'll show you something about that in a second here. But my point is as long as you're running as that user, you can read that file. There are a ton of different applications out here, Chrome Pass, Lasagna, Hack Chrome here, I'm going to demo now. Simply put, all this program does is it reads the file, decrypts it, and spits it out. So let's see this demo run here. There we go. All right, so what we do is we run the program, it reads the file, unencrypts it, and spits it out. That's it, folks. I mean, not much to see there, but the point here that I'm trying to make is we have to be able to prevent any application other than Chrome to be able to read that particular password file. So that's what we're hoping to do, prevent and block unauthorized processes from reading the password file. So I mentioned the actual password string there, but you have to keep in mind that Chromium, as part of their version upgrades, will take backup copies of your cookies files, your passwords, and the like. So you need to create some wildcards around your policy to adequately protect against this sort of attack. You also need to be aware that there are ways an attacker can take your password file and take it out of policy. So for example, you don't want any applications to obviously read that file, but you don't want to be able to rename that file either, or tar or copy or zip, anything that could potentially take that password file out of EPM's protection scope is what we want to protect against. And so now we're going to move on to really my favorite part of our presentation today. We're going to be talking about secrets in memory. This is directly the work of Zeev Ben-Porat, so I want to give him immense credit for all of his research here. Essentially, what I'm going to show you is that passwords within the context of Chrome are in clear text in the memory, and you can view this as a standard user. So let me show you. This is a program called Process Hacker. Again, it's a third-party application that's going to analyze the running memory of Chrome. So we're going into the Chrome properties here, and you're going to see a ton of different strings. These are just characters of certain length. And so we're going to actually filter and find our quote-unquote needle in a haystack here. We already know our password for this example. What do you think it is? Positive horse battery staple. And we're going to go double-click on this because it's found it in memory. There it is, folks. Positive horse battery staple in clear text in the memory as a standard user. Okay? If that doesn't scare you, I don't know what does. So now let's talk about how one could do that, okay? So I showed you the first way, accessing the browser from an external process. That's what Process Hacker was. It's a third-party external process that's reading the memory of Chrome. The other way you could go about doing this is spawning your own Chrome browser. So this would be like a child process, and spinning that up and analyzing the memory, again, very, very easy. The third way, which I find actually really interesting, is dumping the memory of the process, okay? And essentially what you'll do is take the analysis of the data dump, you'll log in, take another data dump, compare the deltas, and essentially you're just left with some really nice passwords. So the only research that I found remotely in this wheelhouse of technology was Mimikittens. This is the only tool that I found that would analyze the browser memory and spit out passwords. But unfortunately, it's dead. This has not been updated since 2016. There's literally no research in the world that's really focused on browser memory credential harvesting tactics, with the exception of Zeev's research here. labs.cyberark.com. If you're not familiar with this site, I highly encourage you to check it out. This is where the labs team posts all their latest, greatest, amazing research, along with our host of tools. There's a ton of stuff in there, so I highly recommend you check out specifically this article if you want to get a really deep technical analysis of my presentation. So now what we're going to do is a series of 3 demos, and hopefully they'll build upon each other, and this will really show you why this is a valuable situation, and more importantly, how CyberArk's EPM can protect against that. So in this situation, again, we've got our needle in a haystack. We take our data dump. We then log in again, this time but with passwords, compare the deltas, and hey, we're left with some passwords. So let's get this demo started. We're going to first start off with, again, demoing dumping the passwords from the Chrome browser using the memory technique I've discussed. In this situation, we're going to log into Chrome using the password manager function. By doing this, this literally loads every single password within that password manager into the memory of that Chrome process. So now we're running our malware. It's reading the Chrome memories, analyzing the strings, and ultimately will spit out 4 different usernames and passwords that just happen to correspond with the 4 usernames and passwords that are here on our browser. It's that easy, folks. But it's also just as easy to protect against this. Using the EPM protection policy to prevent rogue applications from reading that memory, we rerun this attack and watch what happens. Nothing. This is exactly what you want to see when EPM properly blocks this sort of password harvesting technique. It's unable to read the password, and it fails gloriously, right? All right, so now I want to move forward to my next demo. This one gets a little scary here, folks, because we focus mostly on passwords so far. Now we're going to focus on cookies and how, one, easy they are to harvest, but again, what you can do with that. And what we're going to do here, is we're going to hijack a Google Gmail session. What makes this particularly interesting is we're going to actually bypass the multi-factor authentication as part of this attack here. So Zeev's going into his demo account, logging in with a username, a very secure password, and the multi-factor challenge and response. So here you have it. We're going to be putting in the SMS code. You may have your own opinions about SMS, but something's better than nothing, right? So now we're going into, we've authenticated, we've successfully logged in. That cookie is now in the memory of the Chrome process. So now what we're going to do is run this malware, and we're going to spit out our cookies to file, okay? So once the malware runs, it's going to create 4 files. These are the cookies that we can then offload. So now that the attack is done, we'll move the files over to our attacker's machine and continue the attack from there. It's very, very simple, folks. Using a browser extension called Cookie Editor, we're going to edit some cookies. So what we're going to do now is go into the cookie editor and manipulate a cookie and create and basically transfer the values from our compromised machine into our attacker's machine. What we're doing now is we're copying over the properties of Google, whether it's a HTTP only. To be honest, the only real value of any consequence here is that value string. That encrypted value is what delineates and designates that this is the session that we're going to be hijacking. So I'm going to copy that in there. We're going to put a couple more dates in. The expiration is really arbitrary. You can put whatever you want. We'll make this a secure HTTP-only cookie. I'll let the demo play out and save, but suffice to say, we have crafted our first malicious cookie. And for a Gmail attack to take place, you don't need multiple cookies. You only need one. So we'll go ahead, save our cookie, and then we'll just hit Gmail. And again, watch how we are going to be, again, bypassing the authentication, including multi-factor, once we've hijacked that cookie. So now we go to Gmail, and there you have it, folks. We are on Gmail. We're on the same Gmail as our compromised box. So that's, in my opinion, pretty darn scary. And again, I have to beat a dead horse here. This was done as a standard user, no elevated rights necessary. But again, more importantly, EPM has policies directly built to protect the memory of the Chrome process. It's not only from passwords, but for cookies as well. So again, we'll rerun our attack and watch how it gloriously fails. There you have it, folks. Access to the browser's memory is blocked. That's exactly what we want to see. All right, so now, like I mentioned earlier, Chromium isn't just Chrome. Chromium also runs under the hood of other browsers such as Internet Edge. So in this browser demo, we're going to do the same attack that we previously done with a few nuances, but this time we're going to be focusing on Microsoft's Internet Edge browser and attacking Office 365. Essentially, any app that uses cookies is potentially at risk from a session hijack here. Now, in this situation, we're logging into OneDrive using our, again, secure username and password. MFA is not cheap for demos, so we didn't have one in here, but it really doesn't matter. Whether you're using SMS, Radius, SAML, whatever, it does not matter. As long as you've got a cookie that's been deposited on the machine, regardless of the MFA, it's ripe for attack. So that's what we're doing here. We've authenticated, we're running our malware, and it's going to spit out a bunch of cookies. For a OneDrive attack to successfully go down, it's a lot more difficult than just one cookie like what we did with the Gmail session. So what I'm going to do now is a little convoluted here, but what we're essentially going to do is export all the cookies, and then we're going to encrypt them and then import them in with the cookie editor. So while this is walking it through, I'll kind of step you through it. We have successfully exported all the cookie files to disk, okay? So now what we're doing is we're copying them over to our attacker's machine, and now we're going to try to import them en masse. So luckily, the cookie editor application contains some pre-built scripts that will make this a little easy. Essentially, what we're going to do is run this script. It's going to spit out a big chunk of ciphertext that will then copy and paste into a text file that we're then going to import into our cookie editor. So here we have it. We're going to run the browser. We're going to double-click on this encrypt cookies HTML. Let it do its thing. Bam. Let me try that again. Bam. No. Bam. There we go. So we have we have all the ciphertext that we need. We just copy and paste that into the cookies txt file, and then we'll import that into the cookie editor browser extension. So copy this. Now we have our test cookies txt file. All right. Now we just need to go into cookie editor, go into import, pick that file, pick our decryption key, type it in, and we've got imported all those cookies, not just the one. So now we go to find the test cookies one file, click open. We'll type in our password, and then we have cookies. A lot easier than manually doing it one by one, right? So we did 19 cookies just like that. Once we've done that, it's just simply a matter of going to the OneDrive website. As part of our data dump from the original machine, we were included with the URL to our OneDrive site. So we copy and paste this into our browser and take a look. we've hijacked the session. So copy, paste, bada bing, bada boom. There we have it, folks. On our attacker's machine, we have successfully hijacked the OneDrive session of a user, with no admin rights necessary. So that's pretty darn scary. And now we're adding insult to injury by exfiltrating data on top of it. So we're pulling down and downloading files in addition to just hijacking the session. This is what we're seeing a lot of in today's attacks. In circumstances where sites are compromised, data exfiltration is occurring almost more often, if not more, than the actual file encryptions in ransomware events. So let's continue here. I've shown you how easy it is. I've shown you that other attackers are doing this. This is how easy it is without even having to compromise the site. You can just simply buy cookies. This is the Genesis marketplace, folks. This is a dark web underground marketplace for selling, buying, trading of session cookies as a commodity. Cookies are available all over the world. And again, you can get access to many different sites just by purchasing these cookies. Here's just a handful that I wanted to highlight for you. For $59 here, one can buy access to Instagram, Tumblr, Office 365, a ton of consumer-based web apps, all for $59. This one I thought was particularly interesting. For $24 US, you actually get 1,500 different Chrome cookies. What I think is really interesting about this one is that it gives you access to a lot of enterprise applications. So we've got Mega, Office 365, Box, AWS. In the event that any of those, this user was compromised, an attacker could get access to all those sites for simply $24. Here's another one for $17, but it also included browser fingerprints. So in addition to cookies, some websites are further protecting by doing browser fingerprinting. But if you copy those over too, well, it's another way to bypass the authentication. So back to how do we mitigate these sorts of attacks? It's really about, again, blocking unauthorized applications from being able to read the Chromium memory, okay? Now, the two things that I would recommend are this. We want to make sure that the binaries are properly signed by the developer. So Chromium is run by Google Chrome, so you want to make sure that any binaries are properly signed. The next thing is to make sure that the original file name is indeed chrome.exe. Many malware will change the name to Chrome in order to perpetuate the attacks, but if the original property is set to Chrome, this is a good protection mechanism. Now, the last thing I'm going to show you today is by far the simplest way. This is simply asking the browser, okay? Command line arguments, folks, are simple commands that are appended to the end of a command line that allow you to do additional functionality of the process. In this circumstance, Alex was able to determine that the remote debugging capability of Chrome also allowed you to exfiltrate all the cookie information as well. So this is cookie crimes. Essentially, what we're going to do is not do all that. We're just going to run cookie crimes. Simply put, we just launched the browser process with that debugging enabled. So what we're doing is going into PowerShell. We're going to launch Chrome with remote debugging on, and I believe we're going to one of my favorite websites, kli.org. That's the Klingon Language Institute for any of you Star Trek fans out there. So we'll let the demo play out. We've launched Chrome. You can also do this in a headless state, so there's no UI. But once the process is running in debug, we just run the cookie crimes Python script. And this will take a few seconds and then spit out a text file with all of the cookies in clear text in JSON format. Now, I've already shown you twice now how easy it is to either edit a cookie or import them, so I'm not going to waste your time doing it a third time. But to suffice to say, once you see these passwords on screen, that's enough. That's enough to hijack a session. So there you have it, folks. That's how easy it is to use command line arguments to steal the session cookies from a Chrome browser. So how do we protect against that? We really only allow the applications to run within the context that we define, all right? We need to restrict certain command line arguments to not be allowed to run. So the three particular command line arguments that I recommend here is remote debugging port, remote debugging pipe, and headless. Headless doesn't really protect against this type of an attack, but it prevents the browser from hiding the UI. So this is a way that attackers can stay covert. So those would be the three things that I would recommend from a command line argument perspective to protect against this particular attack. So back to the picture of the scared cat and the 5 different ways we've discussed how to skin this cat and steal passwords, steal session cookies, and data from our browser. Again, it's that keyed in data. Keyloggers, folks, hardware, software, it doesn't matter. It logs every single keystroke, including your passwords. So how do we go about protecting against that? Application control and aggressive password management, okay? Then we move forward to intercepted communications, those inline attacks, this network layer or social engineering. This is really where, again, encryption, making sure that you're validating your certificates, making sure you're not browsing on an open network. And then again, end user awareness training. That goes so far. The next thing, again, is secrets on disk. That password file is ripe for attacking, and you have to prevent third-party applications from being able to read that file. So again, this is where EPM's built-in policies will protect against these sorts of attacks. Then we focus on the in-memory attacks. Again, EPM specifically blocks these sorts of attacks. And last but not least, through, again, command line arguments, we can execute this sort of an attack. And again, EPM has the protection policies to protect against that. I think that's the kind of gist of today's session. The work that comes out of CyberArk Labs is pretty awesome. But more importantly, I think it directly helps mature the rest of the CyberArk solution of products. And that's really the takeaway from today's presentation is that the research from Labs immediately impacted and allowed us to create these policies that no other applications are doing. So this really separates us from any product in the market. So again, how does EPM do it? It's denying access to those particular password files, preventing those applications from reading the memory of the Chrome process, and again, stopping rogue command line arguments from running. And that's just the tip of the iceberg, folks. We focused barely on the Chromium process, but there's so many more different applications, solutions, and products that EPM will do an amazing job out of the box in protecting. So from other browsers to FileZilla, PuTTY, SQL Server, you name it. There's a ton of different policies that I would recommend, if you haven't already, enable in your environment today. If you don't have an environment, we've already kind of talked on this a little bit. We do have a 30-day free trial of EPM that I highly encourage you to kick the tires and light the fires. And with that, we have, for 2023, stay tuned to our Attack and Defend Roadshow. We'll be focusing on EPM among other different products and solutions. So if you want to get hands-on with EPM, demonstrate these particular policies, we'd be more than happy to make that happen for you. So with that, it looks like I'm a little over time, but that concludes my talk for today. Thank you so much. Again, it was a pleasure to meet you, and thank you.